All right, we have already discussed how acids are going to form an H plus ion or a proton and a conjugate base when dissolved in water. Okay, so assuming they all have the following symbols, this would be the equilibrium expression. Okay, now also understand that instead of writing H plus, we could be writing the hydronium ion as well. Okay, so they're interchangeable. Remember that. All right, so we call the equilibrium expression for an acid, the dissociation of an acid, Ka. Do all acids dissociate the same in water? Well, no, absolutely not. So you're going to have to remember which acids do what. Strong acids dissociate completely in water, okay, 100% dissociation. So here you see before it is added to water, throw it in water, and you see, bam, you have 100% H plus and 100% of the conjugate base. All right, now do you think this has a large K or a small k? Well, it definitely is product favored, so it has a very large K. And here's a chart. It has the 7 common strong acids. It's best to memorize these strong acids, and then anything that's not a strong acid has to be a weak acid. Okay, so we've got perchloric, which is HClO4. We've got hydroiodic, which is HI. We've got hydrobromic, which is HBr. Hydrochloric, which is HCl, nitric, which is HNO3, sulfuric, which is H2SO4, and hydronium ion, which is H3O+. Okay, see that they all have a very large Ka, so large we don't even give it a value, except for hydronium, which has a value of just 1. All right, now weak acids. Weak acids only dissociate a little bit in water, so we're talking like 5%. So here's before we put it in water. We put it in water, and you see that you've still got a lot of the acid still bound together, and then you have a very, very small amount of hydrogen ions and the conjugate base. So here we're going to have a small Ka, and we are definitely going to be reactant favored, so it definitely does not proceed towards completion very much. Here are some common weak acids. Again, you don't have to memorize any weak acids, but I would like you to just notice their values. So we've got anything from 10 to the negative 1, which would be 0.17, all the way down to 10 to the negative 10th, which would be like 9 zeros, and then the 4 nines. So very different. All right, here's a molecular comparison. So here you see a strong acid, and you see that it dissociates. It is bound here, and then when we dissolve it, it all breaks apart. Okay, so it's all dissociated in water. And here you see a weak acid, and you see that you still have lots of bound molecules, and you have very few that are unbound. All right, here's another depiction. So here we have a strong acid solution. You see all H pluses and A minuses, so it's dissociated. And here you see a weak acid solution. A lot of them are still bound, and then you have just very few dissociated. All right, again, add the strong acid to water, breaks apart completely, 100% ionization, and add the weak acid to water, and you see that you have several still bound. Only some of them, very few actually, will dissociate in water.